Hello everyone, welcome to Neural Networks Analysis lecture recording. This is your instructor Reza Vaezi. In this short lecture, you are going to learn about the basics of neural networks analysis. Neural networks are also known as artificial neural nets or artificial neural networks. If these algorithms are used in well-defined domains, their capability in generalizing and learning the situation is comparable to that of human ability to learn from experience. Their strength lies in that they can handle extended number of attributes and they can be used for prediction and classification similar to decision trees. However, neural nets are a little bit better at finding the strengths between two attributes, and they use some sort of fuzzy logic algorithm to capture the extent of the strengths between variables. As you know, we do not really get into the details of algorithms, especially predictive algorithms. But here is a 10,000 feet view of how neural networks algorithm works. It uses a technique that is called backpropagation, and here's how it works. In the first system, the algorithm uses the training dataset and calculate the output for the continuous target or the distinct outputs for the nominal or categorical target through assigning weights into input variables. So similar to regression, if you want to imagine, I'll give some coefficients or some weights to different attributes, and it will use those weights and the value within the attributes in order to predict the output. And then it calculates the error by taking the difference between the calculated results and the actual values for the target value. So I'll go ahead and compare these two values, calculate the error, and then it will feed the error back into the algorithm in order to adjust the weights for the input variables and calculate new outputs and new target values. Again, after this new values are created, we'll go ahead and calculate the error and feed it back into the algorithm to adjust the weight. So the name backpropagation, because it feeds back the errors into the algorithm in order to make the algorithm better at its predictive task or at its classification task. So if you want to compare decision trees to neural nets, here are the major points. Neural nets can handle numerical values for non-label attributes, and that's only they can handle numerical values, while decision trees were more flexible in that they could handle both nominal and numerical values for non-label attributes. Another difference between decision tree and neural networks is that the neural networks use a complex algorithm that is hard to understand and explain, and the model they generate also is hard to explain to a business user. While decision trees or the model generated through decision tree algorithm was much more easier to understand and explain for business-minded people. However, neural nets generally perform much better when you have many independent variables and many variables that are used for predicting your target variable. In that case, neural nets usually have an advantage over decision trees. However, which one is better, which one makes more sense, which one creates better predictions, you can actually evaluate this in the next lesson when you learn about cross-validation and how to conduct cross-validation. Also, neural nets can be used on target variables that are numeric and continuous. A special version of decision trees can be used on target variables that are numeric or continuous as well, but it is not advised to use decision trees on continuous target variables. However, you can use neural networks for both discrete or categorical target variables or continuous target variables. This concludes the very short lecture on neural nets.